Alright, now the next concept is how to calculate the gradient. So what is exactly the gradient? What does it tell us? Any idea? No? Good. So gradient in short is just a measure of how steep the line is, how steep or how flat the line is. Like for example, so this line is a relatively steeper line. This line, however, is not so steep. Okay? So this line will have a higher gradient than this line. Why? Because it's a lot steeper. Like if you were to climb up this slope, this would require a lot more effort as compared to this one. Why? Because this is, as I said, relatively a steeper line. Okay. So in other words, by the way, gradient is represented by this letter m, small m. Okay. So in other words, the gradient or m is just the ratio of rise is to run. And suppose you want to determine the rise of your line, so that you can do by taking out the difference in y. And suppose you want to determine the run of your line, that you can do by taking out the difference in x. So the formula for gradient becomes y2 minus y1 upon x2 minus x1. Okay. Now let's do an example to further cement this concept. Suppose you have a point A, 3, 5, and suppose you have a point B with coordinates, let's say 7, 11. Okay. And suppose I want to find out what the gradient of line AB is. Right. So suppose this is x1, so this will automatically become y1. And suppose this is x2, so this will automatically become y2. So I'll take the difference in y and divide by the difference in x. So m will be equal to y2 minus y1 over x2 minus x1. So m is going to be equal to 11 minus 5 divided by 7 minus 3. And what's 11 minus 5 going to be equal to? 6? 6, right? Not 7. Yeah. And what about 7 minus 3? That's 4. So 6 upon 4 when simplified is 3 upon 2 or 1.5. Okay. So that's how you calculate the gradient of a straight line. So there's one more thing. Just by looking at the line, you should be able to tell what its gradient is going to be. And by that I don't mean the actual value. I mean just whether it's going to be negative, positive, 0 or infinity. So in that case you have 4 unique cases to remember. So if you have a line like this that's rising, okay, so a line like this will have a positive gradient. Why? Here's your test. What you do is you move towards the positive x-axis, and as you do that you check whether your line is rising or falling. What do you think this line is doing? It's rising, so therefore this will have a positive gradient. The other case is, suppose you have a line like this. Okay. Again, what I'm going to do is I'm going to move towards the positive x-axis and I'm going to see what's happening to my line. Is it rising or is it falling? It's falling. So therefore the gradient of this line is going to be negative. Okay. Let's do another example. Suppose you have a line like this. This is a horizontal line or a line that's parallel to the x-axis. What do you think the gradient of this line is going to be? Take a guess. Alright, suppose I use the formula to calculate the gradient. Okay. So the formula is y2 minus y1 upon x2 minus x1. Okay, tell me one thing. Is this line rising or falling or none of that? You think it's rising? Do you think it's falling or it's doing none of that? None of that. That means the rise or run, the rise will be 0. Okay, and what do you think will happen if you divide 0 by any value? 0 divided by 5, 0 divided by 4, 0 divided by 10, the answer will always be 0. So a line like this will have a gradient of 0. Okay, now we come to the fourth and the final case. I'll just do that here. Suppose you have a vertical line. Okay, so what do you think this line is doing? Is this line running? Is there a horizontal change? Let me tell you what I mean. Is this line going towards the right or left? Or is it just a vertical line? It's a vertical line. So that means if I calculate the gradient here, so again the formula is y2 minus y1 upon x2 minus x1. So here the denominator will be 0. Pick up your calculator and take any value and divide by 0. Suppose you do 5 divided by 0. No. So I'm going to be 0. What do you get? Math error. Okay. You know what does that mean? That means a line like this will have an infinite slope. Infinity. Have you ever heard of infinity? Okay. So a line like this will have infinite slope. Okay. So positive if it's rising, negative if it's falling, 0 if it's horizontal, infinity if it's vertical. Okay. So I want you to copy this, and we'll learn more about parallel lines and perpendicular lines. Okay. But first I want you to copy this. Okay. So the next important concept is related to parallel lines. Have you heard of parallel lines? What have you heard of parallel lines?
They go past each other.
They never meet. Okay. So when two lines are parallel, what happens is they never meet. Achha, why is this important right now? It's important right now because parallel lines have the same gradient. Okay. So I want you to write this down. Note. If two lines are parallel, they will have the same gradient. Okay. So let's say you have line 1, and line 1 has a gradient of, let's say, 3. And let's say you have line 2, which is parallel to line 1. You know what this symbol means? This means parallel. Okay, so if that happens to be the case, then the gradient of line 2 will also be equal to 3 if two lines are parallel. Okay, so if you have a line like this, no, this is not power. This is m1, yeah, gradient number 1, gradient number 2. Okay, power is on the top, it's not at the bottom. Okay, had it been power, it would have been like this, m square. Okay, this means gradient of line 1, this means gradient of line 2. Okay, so we're going to do questions related to this concept, but right now we're just learning what the concept is. Okay, the next most important concept is related to perpendicular lines. Do you understand the term perpendicular? Perpendicular, that's fine. Perpendicular basically means making a 90-degree angle. Okay, so perpendicular means making a 90-degree angle, right? Perpendicular means making a 90-degree angle. So what do you think perpendicular lines suggests? Two lines that are intersecting, and at the point of intersection they're making a 90-degree angle. Okay, so here's a very important note. Okay, I want you to write this down also. When two lines are perpendicular, their gradients are negative reciprocal. Do you remember the term reciprocal? That's okay if you don't, we'll learn it in a while. No. Reciprocal is the process in which the numerator becomes the denominator and the denominator becomes the numerator. Okay, we'll learn this in a bit, just hang in there. Okay. Alright, suppose this line has a gradient of 2 upon 3. Okay? Sun lo pehle. So this line has a gradient of 2 upon 3. So if you have a line that is perpendicular to this line, so you know what its gradient is going to be? Its gradient is going to be negative reciprocal of this value. Yeah, 3 upon 2 is just the reciprocal. Okay, you will also change the sign. So right now this is positive. Okay, it's positive 2 upon 3. So if I just take the reciprocal of it, that will be 3 upon 2. But since it's perpendicular, the keywords here are negative reciprocal. So the gradient of the line that is perpendicular to line 1 will be minus 3 upon 2. So I did two things at once. I took the reciprocal and I changed the sign. Okay, let's just do a simple drill to understand this. Suppose the gradient of one line is minus 1 upon 3. Okay, and you want to figure out the gradient of the line that is perpendicular to it. Take the reciprocal of 1 upon 3. First, ignore the sign. What do you think the reciprocal of 1 upon 3 is going to be?
3 minus 3 upon 1.
Ignore the sign. So it's going to be 3 upon 1. Right? 1 upon 3, reciprocal of 1 upon 3 will be 3 upon 1. That's perfectly alright. Now you change the sign. What is this right now? This is right now negative. Okay, now if you change the sign, this will become now positive. So the gradient of the line that's perpendicular to it will have will be equal to positive 3. Okay, let's do another example. Let's say the gradient of a line is equals to minus 5 upon 2. Okay, and you want to find out the gradient of the line that is perpendicular to it. So what do you think that will be equal to?
Minus 2 upon positive 5.
No. What's the sign here?
Minus.
Minus. Okay, first you ignore the sign. Just take the reciprocal of it.
2 upon 5.
Okay, now you change the sign. So if it's negative right now,
It
it will turn into positive. Absolutely. Okay, let's do another example. Suppose the gradient of one line is, let's say, 4 upon 3. Okay, now what do you think the gradient of the line that's perpendicular to it will be equal to?
3 upon 4.
3 upon 4, but
Minus.
minus 3 upon 4. Okay, so I want you to copy this, and then we'll do, first we're going to learn equation, midpoint and equation of a straight line. Then we're going to do questions related to parallel and perpendicular lines.